In our second video on forces, we're going to discuss forces on inclined planes. Right now you see an image of a free body diagram of a force at an inclined plane. And just remember from vectors, when we had to break our vectors into components, we're going to have to do the same thing here by taking our weight vector and then breaking it up into its various components. Don't be alarmed at the differing notation that you will see for the weight. Earlier we had F with a sub WT. Here there's an F sub G. You may even see W used as the weight. So don't be alarmed by any differences in notation. It's all the same thing. Just make sure that you're consistent with the notation that you choose to use, and make sure that we, of course, as your teachers, understand what you're trying to do. So let's go ahead and discuss these inclined planes. So the center dot, you would create a center dot just as we did on our earlier free body diagrams, which represents the center of gravity of an object. Your weight vector is always going to be drawn straight down. It's not going to be drawn perpendicular to the incline, it's going to be drawn straight down. You're going to break your weight vector up into two components. So the perpendicular force would be, which is perpendicular to the surface, would be the mass times the acceleration due to gravity times the cosine of the angle of the incline. So this is perpendicular to the surface of the inclined plane, and this presses the object to the surface of that plane, as you saw in the earlier picture. We also have a parallel force, and the parallel force would be parallel to the surface, and it would be pointing toward the bottom of the incline, and that is going to be mass of the object times the acceleration due to gravity times the sine of the angle of the incline, which I have denoted by theta. And this is the force that's pulling the object down the inclined plane. And of course we do have our normal force, which is equal in magnitude but opposite in the direction of the perpendicular force. So this is also perpendicular to the incline, but this is pointing in the opposite direction of your force vector that you're using mg cosine theta with. Couple things to notice: as your angle of the incline increases, the normal force is going to decrease and that parallel force is going to increase. So they have an inverse relationship as the angle of incline increases. And when the parallel force increases, that means the object slides down the inclined plane and accelerates. And as our angle approaches 90 degrees, the acceleration is going to increase to 9.8 meters per second squared. Your parallel force will increase until it is equal to the weight, and then your normal force will decrease and approach zero. And those are the basics for doing forces on inclined planes. Again, we'll practice some problems with these in class. And of course, if you have any questions, don't hesitate to let your teacher know you have questions and get those cleared up. Thanks.